Hello everyone, welcome to our presentation on heart disease prediction and early protection. We are a team consistent of Sahan Sandeepa, SATHIRA GURUGE, WATHSULA EKANAYAKE, ASINDU WICKRAMASINGHA and J.A.S. PERERA. Heart disease remains one of the leading causes of death worldwide, accounting for around 17.9 million deaths annually as reported by the World Health Organization. Early detection is crucial as it significantly reduces mortality rates and healthcare costs. With this in mind, our project used machine learning to predict the likelihood of heart disease and facilitates the early interventions to improve health outcomes. Problem description. The process of diagnosis heart disease faces several key challenges. First, late diagnosis significant issue as it often leads to more severe complication or even death. Second, limited access to preventive health care, especially in underprivileged regions, further exacerbate the problem. Third, the traditional methods of diagnosis often rely on expensive and time consuming clinical tests that are not always accessible to all populations. Lastly, the lack of genetic and lifestyle data makes it harder to assess the true risks of heart disease, thus affecting the accuracy of risk prediction models.
In response to these challenges, we developed a machine learning model that predicts the risk of heart disease based on common clinical attributes. Our model provides a more efficient and accessible solution compared to traditional methods. Solution explanation. Our solution involves the application of SMOTE synthetic minority over sampling technique, a method used to handle the problem of class imbalance in our dataset. Additionally, we compared the performance of logistic regression and random forest models, each with distinct advantages for heart disease prediction. This approach offers a cost-effective and accessible screening tool that can aid in early diagnosis, ultimately improving healthcare outcomes through timely intervention. Dataset explanation. The heart disease data used in our study is sourced from the Cleveland Heart Disease Dataset from UCI, a reputed data repository. The data set contains essential medical attributes like age, sex, cholesterol levels, blood pressure, ECG results, and chest pain type, all of which are commonly used in diagnosing heart disease. The dataset also indicates a binary target variable indicating whether or not heart disease is present. 1 denotes the presence of heart disease while 0 represents its absence. We performed through data preprocessing to handle missing values, encode categorical variables, and normalize the numeric features to ensure the data was ready for model training.
Methodology explanation. We began by preprocessing the data using tools like simple imputer to handle missing values by replacing them with the mean of each column. We removed duplicate entries to ensure data integrity and applied label encoder to convert categorical variables into numerical values. We also scaled the numerical features using standard scaler to standardize them for improved model performance. Next, we performed exploratory data analysis EDA using techniques like heat maps to visualize the correlations between various features, which helped in feature selection. In terms of feature engineering, we applied SMOT to balance the class distribution of the target variable as heart disease is often underrepresented in the dataset. For model training, we used logistic regression and random forest classifiers and validated the model using trained test split 80 to 20, confusion matrix, and Prokop analysis to assess their performance. Model selection explanation. We evaluated several models and found that support vector machines (SVM) performed similarly to logistic regression but was computationally more expensive. For our final choice, we selected logistic regression because it is simple, interpretable, and effective for binary classification tasks. However, we also considered random forest, which is well suited for capturing complex relationships in the data and provides valuable insights through feature importance analysis.
I am presenting machine learning model that predict heart disease using real-world medical data. We will apply supervisor learning and compare two models, logistic regression and random forest to find the best approach. This involves data preprocessing, training, evaluation, and model selection. We start by import libraries and loading the dataset, which contain medical information like age, cholesterol level, and blood pressure. We check for missing value and data distribution. Next, we have missing value. Using mean imputation and encode categorical features. We scale numerical data for better model performance. Smooth is applied to balanced class distribution. Now we train two models, logistic regression and random forest. Logistic regression is simple and interpretable, while random forest is more powerful for complex patterns. Now let's evaluate the both model using accuracy score, classification report, and confusion matrix. Random forest achieved higher accuracy than logistic regression. Compare both models. Random forest performed better with 77.71% accuracy, while logistic regression has 69.02% accuracy. This makes random forest the best choice for heart disease prediction. In this Jupyter notebook, we processed medical data, trained and evaluated two machine learning models, and identified random forest as the best performing model for heart disease prediction. This demonstration highlights the power of machine learning in assisting medical diagnosis by providing data-driven insight for better decision making.
Finally, let's visualize the result and summarize our finding. Compute metric and performance. We visualize the model performance using compute metrics for both models, which help us understand the classification accuracy in terms of true positive, true negative, false positive, and false negative. Additionally, we displayed features important to highlight the most critical predicates for heart diseases with features like chest pain type, cholesterol, blood pressure, and heart rate being the most significant. From our result, we observe that the random forest model outperforms logistic regression, achieving high accuracy and better classification performance. While our study was promising, we identified limitations such as the lack of genetic and lifestyle data and a relative small sample size, which could important generalizability. We plan to improve our model in the futures by testing advanced techniques like XGBoost and natural network, integrating real-time data from wearable device and fine-tuning
high performance from optimal performance. To conclude, machine learning provides valuable tools for early heart diseases prediction, enabling healthcare providers to take prevent action and improve patient outcomes. By partnering with hospitals, we can test their models on real patient data and further enhance their efficacy. End of our video. Thank you for watching. We appreciate your time and interest in our work.